I'm presenting this on behalf of my colleagues from the Recod lab at Unicamp. Their approach to this problem is actually quite simple. These boxes in yellow are not always applied. Depending on the run, they are applied or not. And the diversification is also based on clustering, as many other presenters. So I'm going through each box now on the general approach. So the re-ranking they use is actually based on the textual features. So they employ the textual features, re-rank the lists, and then whenever more than one feature is used, they employ the rank fusion based on genetic programming. So if any of you saw my presentation yesterday, it's kind of the same idea, where we have a series of lists based on different features, and we try to obtain the best lists using many list aggregation methods that are found using optimized using genetic programming. So each genetic programming individual is actually a combination of rank aggregation methods that achieve the best result. And then for diversification, we tested 5 different clustering methods, and as we will see later, Birch and agglomerative and average link agglomerative clustering actually got the best results. And then from each cluster we choose a representative image based on a round robin fashion. And then from these representative images we build the final rank list. So the results for our different runs. What is curious here is that for the 4th and 5th run we used all the features we could, and actually the starting point was the same, and the final clustering method, the feature used for the final clustering method was also the same. And because of the genetic programming optimization, we actually got better results in one of the runs and for the cluster recall. And then the F1 measure for the second run was a bit better. So the genetic programming is actually kind of a coin toss in some cases. For the other runs, particularly in run 3, we were allowed to use visual features also, but whenever we chose to use the visual features and we tried to use genetic programming with the textual features to perform the rank fusion, we actually got worse results. So in this case we opted for not using that approach. So this leads to our conclusion that the rank fusion, contrary to the placing task where we used that and got better results, we didn't always get better results with that in this task. Curiously, the cosine measure was used in the individuals found by genetic programming almost always. We found that, we observed that. And the use of both visual and textual features actually improved results, as seen in the runs 4 and 5.
Thank you.